Hello, so today we are going to take a look at this problem called Spiral Matrix 2. It's part of Leetcode April Daily Challenge. So we get an integer n, and we want to generate an n by n matrix filled with elements from 1 to n squared in spiral order. So this is the main complication here, is in spiral order, which basically means we fill the first row, 1, 2, 3, last column, 4, 5, bottom row, 6, 7, and then we keep going. First column again, 7, 8, and then we do the row, we do the first to last column, and then we do the n-2 row. You get the idea, so we keep going until we finish the spiral order. Yeah, so this is the problem. Now, this is very similar to the spiral matrix 1, where that one we get a matrix, existing matrix, and we need to traverse it in spiral order. Yeah, so let's see how we can solve this problem. Okay, so let's see how we can solve it. So I have here a matrix. We'll fill it in spiral order, 1, 2, 3, 4, 5, 6, 7, 8, 9. So one simple solution that we can do is definitely like to keep track of the beginning of the row, and then row begin, and then increase it, and keep track of the start of the column and the end of the column, and just play with all of these pointers, increase them at the right time, and insert in the right position, and then in a for loop do for iteration. That's the most common solution. You will probably find it in Leetcode and in other explanations. But what I want to do here is a different solution that is less variables essentially. And so what we are going to do is, instead of keeping track of all the pointers for the row beginning, row ending, beginning column, row column, and then do four for loops, what we are going to do instead is keep track of the direction. And so what you'll notice is, while we are traversing this row here, what we do is, well, this is 0, 0, right? And then this is 0, 1, and then this is 0, 2. So each time we add 1 to the row, and then we add 1 to the row, and add 0. So add 1 to the column position, and add 0 to the row position, right? And so if we try to think about it this way, here, while we are traversing row 1, so traverse row 1, what we do is we take the row indices plus 0, and then the indices in the column plus 1. And so we can represent this direction here. So this is this direction, and then we have this direction, and then we have this direction, and we have overall 4 directions, and we keep cycling through them until we reach the end, right? And so we can represent this by 0, 1, because we are adding 1 to the row position, and 0 to the row position, and 1 to the column position. So this is basically left to right direction. Or let me write it more clearly here. So left to right direction, we'll represent it with the value 0, 1. Now, what about for this down position? So this is, if we take a look here, this is 1, 0, 1, 1, and then 1, 2, right? 0, 1, sorry, 0, 1, 2, 0, 1, 2. Sorry, so this is actually, this is not the correct value. So this is 0, 2. This is 1, 2, and this is 2, 2. So you can see here, this position, the row position increases. 0 plus 1, 1, 1 plus 1, 2, but the row position stays the same, right? And so here, what this is telling us is that so this is up, down, right? So we'll call it up to down, right? Direction in our case here, this is going to be 1, 0, because we are adding 1 to the row and 0 to the column position. Now what about this direction here? let's write it down. So this one is 2, 2, and then the position of the row is 2 still, the position of the column is 1, and this is 2, 0. So what I'll do here is each time -1 on the column, and then adding 0 to the row, and then here -1 again, and 0, right? So this position is, direction here can be represented with 0, -1. Basically, we are, the direction represents what you should add to x or to I, and what you should add to j, okay? Okay, so what this would mean here is that, so this is right to left, right? So right to left direction is going to be for us here -1, 0. Sorry, 0, -1, right? Now let's see bottom, the other direction, which is down to up, right? So down to up direction. So what is the value there? So here, what is the value here? This is 2, 0. This is 1, 0, and this is 0, 0, right? And so what are we doing here? We are doing -1, -1 in the row position. So it's -1, 0, and so this can be represented with -1, 0, right? And so for our spiral order here, what is the order of directions that we should take? So if we have the order of direction is we should go right to left first, sorry, left to right first, then we should go up to down, then we should go right to left, then we should go down to up, or bottom to up, and we should keep doing this. We should keep doing this until, because when we reach 8 here, we'll try again to do left to right until we reach a position that we've seen before, like 4. So basically what will happen here is at 8, we will go to 9, and then we'll try to go to 4, but 4 was already visited, so we should not visit it. So to simplify our logic here, instead of coming up with a custom logic, we can just maintain a scene set, right, which will contain x and y values, or I and j values, and basically we can change direction when we reach a scene cell, when we reach a cell that is already seen or already visited, right? So this is the main idea, because what we'll do here is, for example, let's say we'll do 1, 2, 3, and then we'll change direction, right? And we'll do 4, 5, 6, 7, and then we'll go up 8, 9, and then when we reach 4, it's already seen. So try to change direction, but then we'll have already seen this again. But if we had more, right? If we have more data, we'll see that 4 is seen. We'll go down. Let's say we had more data after 9, more values after 9, right? So this is kind of the main idea here. And so what we'll do is just have an array like this with these directions, and then start for the first direction. We'll just add 1 each time. So yeah, let me code it up actually, just so that it's the solution is a little bit more clear. So what we'll do is we'll have our directions array here, which will have the values that we said here, which is 0, 1, 1, 0, and 0, -1, and -1, 0. So one thing I want to clarify is that the order here is important. This is the order of the spiral traversal. The other thing is that the values here represent what we will be adding each time we want to go to the next cell, right? And to change direction, we just add +1, right? And to do a second tour, we just need to go from here, from this position. So this is 0, 1, 2, 3. To do a second tour, we just need to go from here to 0, which can be done by doing the current direction, which is noted by D, plus 1, and then modulo 4, the length of the directions list. And so when we reach 3, we'll do 3 plus 1 modulo 4, that will be 0. We'll go back to do this row here, and that's exactly what we want to do, right? We want to, once we do all the traversals until down to up, we want to go again left to right and keep going again, right? Until we until there is nothing to do anymore, right? So that's the idea here. I hope that's clear. So once we have our directions, right, we can have a list to add the values, and then we will have a counter where we'll initialize to 0, initialize to 1 because we want to start from 1. And then we'll just keep going until we fill all the values, which means when counter is equal to n squared, right? And we'll of course initialize our res value. We'll do that later. And then for our, we'll initialize x and y to 0, right? That's the start position. And so this is going to be counter. And now how do we add the direction? As I said, we would use the value here to know how to transition to the next cell. And so what we're going to do is we'll have dx and dy, which is the transition here, is going to be directions. D, and D here will start at 0 because that's we start here, right? Which means that we'll add dx is 0, dy is 1. So for the first one, the left to right, we'll keep adding to the index of the column, right? Because that's what we are doing, we're traversing a row. And so for that one, once we have the dx and dy, we will say our next x and our next y are going to be x plus dx and y plus dy, right? And then after that, we'll check if these values are within the boundaries. And because when we reach here, right, and we are out of boundary, we want to change direction and go up to down, right? And so that's what we are going to do here. So and y is less than n. And the other thing is to handle the case where 9 we go to 4. 4 is already seen, so we don't want to go there, and so we will do that here. And we want to make sure that we have not seen that new cell again. If it's not in scene only, that we go traverse it. But we should not forget to add to scene x and y here. Okay? And now what we need to do is just reassign to x and y and x and y, so that in the next iteration we'll add to this new position, we'll add counter, right? Now, if not, for whatever reason, either the values is out of bound or it's not seen, we want to change direction. And so what I said to change direction is just to add 1 and then do modulo, of course, for the case where we need to do a second round, right? And so otherwise, we want to increase d plus 1, d plus 1, and then we want to do modulo the length of direction, which is 4. Okay, and now our dx and dy should be directions d, right, for the new direction, and we are going to reassign x and y to the previous x plus dx and the previous y plus dy. And this will work because here we have, let's say here 0, this is 0, 1, 2, this is 0, 2, and so here to change direction to 1, 0, we'll add 1. It will be 1, and 2, we are adding 0, so 1, 2, which is exactly what we want because it's this position, right? We want to start from 4, and so this works out because we are adding 1, and so skipping this one because we've already added it, right? And so that works out well here. And now we need to increment counter so that the next value is, once we set 1, the next value is 2, the next one is 3, and after that is 4. And so we will do counter plus 1 here. And that's pretty much it, actually. And then at the end we can return res. Okay, so I have here the solution that we just saw in the overview. So first we initialize the result matrix that we are going to return. We initialize it with 0 values everywhere. And then we have the directions array, the same direction array that we saw. And we start with the current direction here with the first one, left to right. And the counter starts out at 1. We start A and J, or the index of X and Y, at 0. And then we have our seen or visited set. And we go until we reach n squared, which is the final value we want to assign. And each time we assign counter. And we add to the set of seen values, we add X and Y. And then we take the current direction, we add it to the next, we add the direction values to the next cell indices. And we check that we are within the boundaries and that we have not visited it yet. Only then that we assign these next values to X and Y. But if we are outside the boundaries or it's already seen, that means we need to change direction, and so we go to the next direction with this. So it's either we go from 0, 1 to 1, 0, which means going for up and down to down direction, or if we are here already, which is bottom to up for the first column, for example, for the first traversal, we want to change direction and go left to right again, and so we do +1 modulo 4 so that we can go here. This can be, you can also do length of directions, and then we add those values to X and Y, right? And then we assign X and Y to these updated values, and we increment our counter so that next time we set the updated value here, and then at the end we return our result matrix. Yeah, and that's pretty much it. Okay, so now that we have this solution, let's see how the time complexity here. So we will do at most O(n squared, right? Because each time we increment counter by 1, and then once we reach n squared, we exit the while loop. So we have at most this much, these many iterations. And so that's the only for loop, that's the only iterations we have. So overall, our time complexity here is this. For space complexity, we are using this extra set, right? We are using 4 here with this list array, list directions. This is constant time. We are using O(n squared for the output. And so our space complexity here is O(n squared as well for the output. But if we didn't count the output, then we'd have an extra O(n squared as well for set. One slight optimization that we can do, it doesn't matter much with the space complexity because we have the output, but we can remove this scene here, and instead what we do here is just check if this value was already assigned a value in res, right? Because that will mean it's assigned. And what doesn't mean it's set a value. So if its value is different than the initialized value, so if it's bigger than 0, that means it's already it was already set, and we can that way get rid of scene, get rid of this as well. Yeah, so actually only if it's not set that we want to do this, right? So only if it's equal to 0, which means not set. And now let's run it. Okay, so that's accepted. Let's see if it passes test cases. Yeah, it does. Yeah, so that's so that makes it better. And with this solution, this direction solution, we don't have to do each direction separately in our loop. Instead, we can do them all in one go. Yeah, and that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.